Alright, today we're going to start talking about some applications of quadratic functions. The first one is, determine whether the quadratic function f of x equals 3x squared minus 6x plus 8 has a maximum or minimum value. Then find the maximum or minimum value. Well, a max or minimum value, as we started to talk about, happens at the y-coordinate of the vertex. So our task is basically to figure out which way does this parabola open. Since it has a positive 3x squared, this one's going to open up. And if it opens up, then we know that it has a minimum. So that's the first question. Does it have a max or does it have a min? Our second task is to now find the actual vertex of this. So for that, we're going to use our standard form formula. I'm going to do x equals negative b over 2a. So in this problem, x equals negative times negative 6 over 2 times 3. 6 over 6 is going to give me 1 for my x-coordinate. For the y-coordinate, I'm just going to plug that in. 3 times 1 squared minus 6 times 1 plus 8. 1 squared is 1 times 3 is 3. Minus 6 is negative 3 plus 8 is going to be 5. So the vertex here is at 1, 5, which means that my min happens at 5, the y-coordinate of the vertex. Okay, a second application of quadratic functions models the height of a propelled object as a function of the time elapsed after it is propelled. This is really talking about something like a ball thrown in the air or a rocket ship that launches. Basically, we're talking about a parabola that's going to open down. Something like this. A ball goes up into the air and then it comes down from the air. A rocket ship launches up in the air and then it comes down. We have an equation to model this. It's S of t, S is standing for position in this case, equals negative 16t squared plus the initial velocity, which we write VO times the time, plus the initial height, which is S sub O. So V sub 0 is like initial velocity, the velocity at time 0. S sub 0 is the initial height, the height at time 0. Okay, so now this one says a ball is thrown directly upward from an initial height of 50 feet. So my initial position, my S sub 0, is 50 feet. And an initial velocity, my V sub 0, is 144 feet. So the first thing they want us to do, part A, give the function that describes the height of the ball in terms of t. So we're just going to plug this into the formula that we wrote right up here. S of t equals negative 16t squared plus my initial velocity, 144, times the time, plus my initial position, which was 50 feet. So this is the equation that we're going to use for the rest of the problem. I do not expect that you memorize this formula. I would give you this formula on a quiz or a test, but I do expect that you would know how to use it, like in part A. Okay, B says determine the time at which the ball reaches its maximum height and the maximum height in feet. So again, whenever I'm asking you questions of max or min, your clue is to find the vertex. So I'm going to use standard form formula again, x equals negative b over 2 times a, which in this case, negative 144 over 2 times negative 16. Negative 144 over negative 32 is going to give me x happens at 4.5 seconds. And then to get the y, I'm going to plug that in to the original equation. So y is negative 16 times 4.5 squared plus 144 times 4.5 plus 50. and I'll just calculate this, so I get y is 374 feet. So this now tells me that at t equals 4.5 seconds, this ball reaches its maximum height of 374 feet. The next question asks, for what time interval will the ball be more than 200 feet above ground level? This question is going to require me to write a quadratic inequality. So I'm going to go back to my equation that we wrote in part A, and I want to know when that equation, which is representing the ball, negative 16t squared plus 144t plus 50, that's representing the height of the ball. I want to know then when that is greater than or equal to, or just greater than, actually works, is greater than 200 feet. Okay, now in solving a quadratic inequality, we have to move everything to one side. We're going to have to find our critical values. Then we're going to have to put them on a number line and test regions. And then we'll have our answer. So I'll go ahead and subtract the 200 over. I don't know how to factor this off the top of my head, so I'm just going to do the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So on this one I'm going to calculate that and get that the times are 1.2 and 7.8 seconds. Okay, so now I'm going to go ahead and put those values on a number line. 1.2 and 7.8. And then I need to test my regions. So my easiest test would be x equals 0. If I plug that in, I get negative 150, which is not greater than 0. Then I think I'm going to test x equals 2. When I plug that part in, I get a yes. And then if I tested a number like x equals 8 or x equals 10, again I get a no. So where am I shading in between these two numbers? So my answer to this one is going to be that I am more than 200 feet between 1.2 and 7.8 seconds. So on my note sheet, which I'll post on Schoology, your steps for a problem like this, if I were to write them out, would be to write an inequality, get the equation equal to 0, test your regions, or solve with the quadratic formula, and then test your regions. Okay, one more question regarding this problem. After how many seconds will the ball hit the ground? So this is when I want to know that the position would be 0 feet. So I'm going to set my equation that we again wrote in part A, negative 16t squared plus 144 feet plus 50. I want to know when that hits the ground, which means that its position is 0. Again, probably the easiest way to solve this would just be to do the quadratic formula. So I'm going to do opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is going to give me two answers. I get negative 0.33 and I get positive 9.33. Now I really don't care about the negative answer because that would be representing a time before I've even launched the ball. So the answer that I care about is that after 9.33 seconds, the ball is hitting the ground again, having a position or a height of 0 feet. Alright, a third application has to deal with geometry. Goes back to area and perimeter. The question says a farmer has 2,000 yards of fence to enclose a rectangular field. So remember, when we're talking about a rectangle, we've got length and width. And if the farmer has 2,000 feet of fence to enclose all of that, then we've got x plus y plus y that has to add up to 2,000. That's just perimeter. Another way we could say that a little bit simpler is 2x plus 2y has to add up to 2,000 feet. Even better, if we solve for one of those two variables, we could solve for x or y. I think I'll just solve for y. So I would say 2y is 2,000 minus 2x, and then I could even divide by 2 to make it even simpler and say that y is 1,000 minus x. So now when I'm looking at my rectangle, I can think of this all in terms of one variable, which is usually very helpful. Alright, so question A says express the area A of the rectangle as a function of x, where x is the length of the rectangle. So this is good that we already solved for y. So our area, remember area formula is length times width. In my rectangle over here, it's just x times 1,000 minus x. So as a function of x, I should write a of x is 1,000 x minus x squared. As you can probably tell, this is going to be a parabola that opens downwards because of the negative x squared. So now I'm going to just reorganize it so that it looks more like a parabola. Negative x squared plus 1,000x. Part B of the question asks what dimensions will give maximum area and what will this area be. So now again, we're seeing that keyword maximum or minimum. This one will have a maximum because it opens down. Parabolas that open down have a max. So again, I'm going to do my x equals negative b over 2a formula. Negative 1,000 divided by negative 2 gives me 500 for x. For y, I'm just going to plug that in. Now, I can find y either by going back to my a of x formula, or I could also go back to this formula where we solve for y. Y is 1,000 minus 500. That one's actually a little bit easier for me, so I'm going to do that. So I get that y is also 500. So my maximum happens when x is 500 and y is also 500, but then they also want to know what will the area be. So when I find area, length times width, I'm just doing 500 times 500. I get that the area would be 25 with 4 zeros on the end of there, so 250 yards squared. Okay, so the dimensions are 500 yards by 500 yards. That's for the maximum area. And the max area is 250,000 yards squared. Right, question 4 says find the values of c so that y equals x squared minus 4x plus c has exactly 2 x-intercepts. So when we're thinking about 2 x-intercepts, what I'm thinking about is the quadratic formula and specifically the discriminant. If you'll remember, a quadratic function has 1 x-intercept when the discriminant is 0. It's going to have 2 imaginary intercepts if the discriminant is negative. So that means that if it has 2 real x-intercepts, we're looking for when the discriminant is positive. So for this problem, I'm going to set b squared minus 4ac greater than 0. Now I'm just going to use the numbers that I know. So in my problem, b is negative 4, a is 1, and c is what I don't know. But I can still do quite a bit of solving. Negative 4 squared is 16, minus 4c greater than 0. I'll just add the 4c to the other side, divide by 4. So I'm getting that c is less than 4. Another way to write this in interval notation would be from negative infinity to 4. Okay, and the last application that we'll look at today says that the sum of two numbers is 244. I don't know what the numbers are, so I'm just going to start with x plus y equals 244. Find the two numbers that will make the product a maximum. So I want x times y to be a max. This one's similar to the first problem that we did on this page with the rectangle, in that even though I'm starting with two variables, I want to solve for one in terms of the other. So I'm going to solve for y again, and I know that y is 244 minus x. So now when I'm writing this function that I want to be a maximum of x times y, I'm going to plug in that y is 244 minus x. Now I can go ahead and distribute, so I've got 244x minus x squared. Again, now I can tell that this is a parabola that opens down, if you want to rearrange it, so it looks like that. That might be good. So my function that I want to make a maximum is negative x squared plus 244x. This is a parabola, like I said, that opens down, so now I'm able to find the vertex, because that's where max and mins happen. So negative 244 over 2 times negative 1 tells me that x happens at 122. And y, again, I have two choices where I could plug it in. I could go back to the function right here, or I could also go to this equation for y. Again, I think the original equation for y is a little bit easier. 244 minus 122 is also 122. So both x and y equaling 122 will make their product a maximum and their sum be 244. So if there's one thing I had to summarize from today, find the vertex. The vertex is the answer to the problem most of the time. You're trying to find maxes and mins, and those happen at the vertex. So as soon as you have an equation, which hopefully you're able to find either by getting variables in terms of each other, like we did on problem 3 and 5, or by writing an equation like we did on question 2, once you have that, find the vertex. And from there, you can work with what you've got. Good luck. We'll talk about this tomorrow.